numbers, and we're going to categorize things today too. So this is a big Venn diagram. Numbers can be placed into different categories. Category options are irrational, rational, integers, whole numbers, and natural numbers. So every single number can instantly be split into two separate categories. The first category on the left is rational. Rational numbers can be written as fractions, repeating decimals, or terminating decimals. What is a repeating decimal? Yeah, it's got a line over it. What is a terminating decimal? No. What does terminating mean? It ends. So 0.25, 0.3, 0.975. It doesn't continue on forever. It probably doesn't have a pattern to it, but it ends. If a number is not rational, it is irrational. Irrational numbers are crazy decimals. They never end. There's absolutely positively no pattern. What is the most common irrational number? Pi. Pi is the most common irrational number. It doesn't end. It goes on and on forever. If you categorize irrational, that's the only thing it can be. If you categorize rational, you have to look and say, okay, is it a positive or negative whole number? Meaning, is it an integer? If you say yes to being an integer, then you check, is it a positive whole number, which is a whole number? And then you look at your whole numbers and you check, is it a whole number excluding 0, which are called natural numbers. Think of natural numbers like what you teach your little siblings to count. You don't teach them to count with 0. It's like, okay, we're going to count 0. Like the first number you teach them is 1, and then going up. So if I gave you a number like -3, if I want you to list every category it belongs to, what's the first thing you check? Is it rational or irrational? Rational. Because you say yes to rational, then you check. Is it an integer? Yes. Because you said yes, then you check. Is it a whole number? No. So -3 is rational and an integer. How about the square root of 16? Rational? It's 4. So rational? You can't jump that far. Rational, integer, whole, natural. How about the square root of 27? That is irrational. The square root of a number, if it's not a perfect root, is irrational. The square root of 27 is some long, nasty decimal. I really don't even care what it is, but it never ends. It never has a pattern. Okay? All right, so let's practice this then. Take a minute, go through and check rational or irrational, and then we'll do it together. Check whether each number is rational or irrational. -95.51 with a line above it. Rational. What type of decimal is that? Repeating. 2/3. Rational. It's a fraction. 3 pi. Irrational. Anything with pi is irrational. The square root of 25. Rational. The square root of 17. Irrational. Very good. Very good. For each number, determine if it can be written as a fraction, then state the reason. This is weird, but answer reason first. Answer reason first. Okay, so we look at this, 0.63. Terminating, repeating, or neither? Terminating. It ends. If you say it's terminating or repeating, then it's yes. 0.8 with the line above it. Terminating, repeating, or neither? Repeating, can you write it as a fraction? Yes. 0.555 ... Terminating, repeating, or neither? Repeating. That ... means it's going to continue on. If that was, then they would have written that. Yes or no? Yes. 0.581372 ... Terminating, repeating, or neither? Neither. Can you write it as a decimal? No. If you say neither, then you say no. Why does your calculator go 0.555555556? It's rounding for you. So technically that's a repeating decimal, but your calculator knows it's supposed to round. Okay, take a minute. Determine whether or not those numbers are integers. Yes or no? You're determining if it's an integer. What's an integer? Positive or negative whole number. So we should not have decimals, correct? Negative 89.88. No. 13/12. No. Negative 782.97. No. Negative 32. Yes. Negative 8/4. Yes. This is what Caden was asking me. Can I simplify? Always. Always actually divide that if you can. Negative 8 divided by 4 is a negative 2, which then, yes, is an integer. Okay. Use the names to label the diagram, then place the numbers in the correct region. Okay. So we have 2 circles and 2 rectangles. Help me out. Where am I putting my labels here? The bottom one is here. Whole number. Okay. Top left or top right? Rational. Which would, by process of elimination, leave me integers here. Agree or disagree? I like it. Okay? Take these and write them in the correct category. We'll go over them together. There's 5 numbers there. Write those numbers in the correct category. Place all of them in there, all 5 of them. There's something I told you about that. Negative square root of 81 is negative 9. All the way to whole?
Oh, no.
Just to an integer. Very good, because it's a negative. So negative square root of 81 stays an integer. Negative 4 square root 13. Okay, Jackson asked me a question, and it's a valid question. He typed that into his calculator, not a bad strategy. And he said, how do I know if the calculator is rounding or not? Did he need to type this into his calculator?
No,
Why not?
because it's the square root of so
Yeah, if it ends up being a decimal at all on a square root, it's irrational. It carries on forever. Okay, good question. 0.69 with a line above it.
No, rational.
Rational, irrational?
Rational.
Rational. 0.69, the line above it. 45. 37.
Whole number.
Nicely done. Today's homework, you are not going to have to show any work. But what's my rule? In math all day. If you get done with your homework, that's totally fine. Go work in your pie chart. See how many topics you can fill.